In this video, we're going to continue examining how to rationalize the denominator of radical expressions. However, if we take a quick look at the two examples on the screen, we'll see these are different than the ones we worked with before. In the previous ones, we've only had a radical or a coefficient with the radical, a monomial. In these, we have a binomial. We see a plus sign, we see a minus sign, we see two separate terms. And so the process is going to be the same idea on how to rationalize, but you're going to use a different clever form of one. So you need to multiply to get rid of any roots with a binomial. You need to multiply by the conjugate, which we've learned before when dealing with imaginary numbers. Now the conjugate is going to be the same terms. So if I have a, let's say, plus the square root of b, the conjugate are the same terms, but the opposite operation. Now, the reason why this is you can go back to when you learned how to find the product of the sum and difference of binomials, a plus b times a minus b. If you were to distribute, you would get a squared plus ab minus b squared. These middle terms would cancel, and you're left with a squared minus b squared. The first term squared and the second term squared. Well, if I square root, the square root's gone. And what happens is by these middle terms canceling, all the roots are going to cancel. So the reason why it works goes back into the product of sum and difference of binomial. What we need to remember is how to find the conjugate of a radical expression, which just means take the same term on the left, same term on the right, and just change the operation. So if I'm going to look at example 1, 3 over 2 plus the square root of 5, well, I have to rationalize the denominator, so I'm going to multiply by my clever form of 1, which is going to be 2 minus the square root of 5 in the bottom, and the same thing in the top, 2 minus the square root of 5. Now, when actually doing the multiplying, you need to be careful. Always put parentheses around your binomial expressions, even the ones in the given original problem, because that tells us we have to distribute. So the top with distributing is easy. 3 times 2 is 6, and 3 times negative radical 5 is negative 3 radical 5. Now distributing the bottom is going to be a little more complicated at first, and then hopefully you'll notice the pattern for making it a little bit quicker to do. And the pattern comes from this whole idea of the sum and difference, the product of binomials, making a simple binomial expression. So I would do 2 times 2 as 4. 2 times negative radical 5 as negative 2 radical 5. 2 times positive radical 5 is positive 2 radical 5. Now radical 5 times negative radical 5 is negative. Well, the square root of 5 times square root of 5, well, the square roots are going to cancel. So I'm just left with negative 5. And what happens is the negative 2 radical 5 and positive 2 radical 5 cancel. You notice I no longer have a radical in the denominator. I rationalized it. And so in the bottom, what I'm left with is a 4 minus 5. And so what does that give me? That gives me 6 minus 3 square root of 5 in the top and a negative 1 at the bottom. Now this is the fun part. This is the tricky part for many students is remember this negative 1 goes to both terms. And we learned that back in chapter 6 when we divided by monomials. If you have an expression in the top separated by addition subtraction signs, the denominator gets split to both terms. So watch this. 6 divided by negative 1 is actually negative 6. Negative 3 divided by negative 1 is actually positive 3. So my final answer is actually negative 6 plus 3 square root of 5. Let's try this example. I have 4 minus radical 3 in the bottom. So I'm going to rationalize it by multiplying by 4 plus radical 3 in the top and 4 plus radical 3 in the bottom, my clever form of 1, just changing the operation. Anything that's a binomial gets parentheses put around it to assist me with distributing, and then I distribute. Distributing the top, easy, 5x and 4, 20x. 5x times radical 3, well, that's just 5x radical 3. Distributing the bottom. It involves a little thinking at first, and then we'll probably see a shortcut in the next example set. What you do is you take 4 times 4, and that gives me my 16. I take 4 times radical 3, and that's positive 4 radical 3. Negative radical 3 and 4 is negative 4 radical 3. And negative radical 3 and positive radical 3 is a negative 3 because the radicals just cancel. And you notice 4 radical 3 and negative 4 radical 3 cancel. I have rationalized the denominator. And I'm left with in the bottom just 16 minus 3. And so let's simplify. 20x plus 5x radical 3, we're just going to leave alone. And 16 minus 3 is 13. And so that is my final expression.